All right, example 3, section 11.3 can be very, very interesting. They want us to find the area of this whole hexagon. Now, we were given in our core concept a formula, area of a regular polygon. Polygon, any shape, it was so many, any sizes. So this is a hexagon, 6 sizes. That formula is area equals 1/2 times AP. Okay. Now remember, P is NS, which is number of triangles times the base, which is labeled S in this case, and A is the height in this case. So what I'm going to do is I'm going to pull this triangle out so you can see a little bit better what we're dealing with. Okay? And we know it is a right triangle, so we can do all kinds of stuff with the right triangle. Remember, there's the 45, 45, 90 degree triangle. There's a 30, 60, 90 triangle. There's SOHCAHTOA with the trigonometric functions and ratios. Okay. In order to use this formula, we need to know what S is. We need to know what A is. We have to find S. So S goes from here all the way to there, right? So basically this is like half S. And we need to find A. Now this says the diameter is 32 units. From here to here is 32. And this is the very center of the polygon. So that's the half point. So we know what this length is of this triangle. The hypotenuse is half of 32, is just 16. Okay. Now, this is all the information we have. We have to find more information. We're going to have to use things that we've learned previously to find these lengths so we can plug them in to our final formula. We're going to use trig functions and ratios to do it. Trigonometric, whatever. So, we can, however, find this angle. Well, we're going to need to find this angle because we can't use the 90. If we're going to use SOHCAHTOA and we want to find this or this, we need one of these other angles. We can't find this one, but we can find this one. Remember, I'm just going to do a little dotted here. In the previous core concept or the vocabulary, the central angle of a regular polygon. Central angle of a regular polygon. Okay, that's central angle of the polygon. And that was found by taking 360 degrees and dividing by how many sides there are in the polygon. In this case, hexagon is 6. There's 6. Okay? So 60 degrees. This is 60 degrees. Which makes this right here, this angle, 30 degrees. 30 degrees, I hope you can see that. I'm writing a little bit smaller and smaller. 30 degrees, because it's half of 60, okay? Because we're only looking for half the triangle. So this is 30 degrees. Okay? So this is finding central angle. That's what we did here. All right, now that we have the 30 degrees, this is a 30-60 triangle. 30-60 triangle. And 30-60 triangle, you can do all kinds of stuff. There was where the I don't have them memorized. I have to go back through my notes. We can do the 30-60 triangle theorem, or we can do SOHCAHTOA. And I'd rather do SOHCAHTOA. It's just easier and faster, I think, because I know how to do it. The 360 angle triangle theorem is pretty easy too, but I don't have it memorized. Without practice, it kind of leaves my mind. I can go back to chapter 7 and look for it, but for sake of time in this video, I'm just going to do SOHCAHTOA. So if I want to find this length here, which is adjacent to the angle, adjacent over hypotenuse. What is adjacent over hypotenuse? AH, so C-A-H, cosine. SOHCAHTOA, cosine of our angle, which is 30 degrees, equals adjacent. In this case right now, it's just an unknown, A, over that hypotenuse, which was 16. So 16 cosine 30 degrees equals the height. 16 cosine 30 equals 13.86. 13.86. Okay, so that's A. Now we need to find S, opposite over hypotenuse. Sine of 30 equals opposite. In this case, it's going to be half S. You know, let's just, to make it simple, let's just call it X for right now. Okay, calling this X. And that's over the hypotenuse. So we get 16 sine 30. I hope you can read it. 16 sine 30 equals 8. Well, that's cool. 8. Now, remember, x equals half s, so half s equals 8. Okay? And to get s by itself, we're going to multiply both sides by 2, so s is going to be 16. So this is actually 16. Boy, I hope I did that right. Did I do that right? Or did I mess that up? No, I think that's right. What I'm confused now is the height. Adjacent over hypotenuse. 13.86. Let me double check it. Yeah, okay. All right, now we have our information. We have our A, and we have our S. So let's plug it in. Our area equals half times A, which is 13.86, times capital P. Capital P is NS. So 16 times N is the number of sides, 6. Okay, I'm just going to plug all of that into the calculator. So we get 13.86 times 16 times 6. Divide everything by 2. I got 665.107. I'm going to round it. So 665.11, and that's square units. That's my answer. Okay, that is why I covered those certain chapters, so you had the proper information to do these kinds of questions. All right, so it's a lot to take in. You need to go back and review this video, pause it occasionally, try to understand it so you can do it. Because I used quite a few different theorems that we've learned in chapter 7 and in chapter 9. All right, good luck, guys. You can do this. You can do hard things. Okay.